So, morning everybody, and thanks for that introduction, Simon. So, I've done my introduction, and I know we're sort of running a little delayed for our schedule. So, we were due to have about 40 minutes, which the clock is still counting that. It just means you're a bit delayed going to the coffee break, I'm afraid. But yeah, I think without further ado, I mean, obviously we've heard from 3 of our panellists today, but I will just come to each, and then I'll give Mel a chance for an introduction. So, Jake, could I come to you in the context of just introducing perhaps your background as well as what you're doing today at Alchemab and what you'll bring to this panel session, please?
Yes, yeah. So I've spoken about Alchemab. Yeah, so perhaps to introduce myself. So my background is kind of in immunology and computational biology. And really, I've spent the last 15 years or so developing new technologies for developing antibody therapeutics. And I'm just kind of excited by big scientific challenges and new technology. It's kind of exactly the kind of thing we're doing at Alchemab. So what will I bring to the panel? Perhaps a different kind of perspective on ways of harnessing the body's defenses. So I think we typically think about immunotherapies when we think about harnessing the body's defenses, but the kind of Alchemab approach is a slightly different way of harnessing the body's defenses, as well as maybe some thoughts on any kind of technology innovations that are going on here in this area. Lovely,
thank you, Jake. James, if I might, with the many hats that you wear today, as well as perhaps your previous experience, what do you want to bring today?
So I think the main thing for me is it's really interesting hearing you guys talk about certainly what you were saying about those sort of resilient and resistant individuals, and really how we have 2 problems in the pre-hospital space. One is it's a really under sort of researched area. I think a lot of the disease that you even what I've talked about today, or similar in terms of your drug discovery and development, none of it's really focused on that really early on hyperacute phase. And actually it was really interesting, when you were talking about these resilient individuals. If we just take the example of cardiac arrest, so again, 50% of the work that we're doing, if everybody here now had a cardiac arrest, just this row of people on the end would survive, which is quite scary. Yeah, maybe. So we know despite all the improvement in medical care over 40, 50, 60 years in terms of management of cardiac arrest, we've not really had any change in the survival. And actually there's something about that's really interesting what you brought up around resilient individuals that we see day to day, and actually that's who are the survivors from cardiac arrest. So we go to lots of different patients, and the vast majority of people have cardiac arrest secondary to a heart attack. That's the most common thing that we see. And really how long you're in cardiac arrest determines obviously the likelihood that you are going to survive. The longer you are in cardiac arrest, the longer your brain's not had oxygen for, and therefore, even if we get your heart started with all the kit, actually, are you still going to be as functionally sort of able as you were, even if you leave hospital? And there's no real rhyme or reason as to who those patients are who we restart their heart. So we all know that if we do CPR and get shot and things like that, that's great for you. But actually, we'll also go to the people who didn't really have a lot of that chain. Their heart hasn't started for the first 45, 50 minutes by the time we get there. Then we'll get there and it will restart, and those patients will leave hospital. And they'll be exactly the same group of patients as your 40-year-old man who has a cardiac arrest in the gym, who has everything going for him and the complete chain of survival, and he doesn't survive. And what you say about the resistant and sort of resilient individuals is fascinating. I wonder whether that has part of it.
You're making me think we need to branch into this area.
Maybe we'll talk after. But actually, yeah, whether there is something about that resistance in the blood-brain barrier that you're much more resilient to hypoxic insult in certain patient groups.
Lovely, thank you. Simon, anything in addition you'd like to add as your intro?
I think I want to buy myself a mobile defibrillator so I can be assured of survival. So from my perspective, I'm a patent attorney. I've been in the profession for 24 plus years. And what I often say is we tend, as patent attorneys, we tend to see things on our desk about 10 years before it hits the clinic. Sometimes it's longer than that. You know, I've been involved in cases where there's only been a couple of years left of the patent life, which is 20 years before something's actually hitting the clinic. So from my perspective, I get to see a lot of the new technologies coming on stream about 10 years in advance. And also, it's not just the new technologies which are being developed, but also combinations of, say, for personalized medicines, you know, there's the diagnostics component coupled with the therapeutic and also new ways of drug delivery. So a lot of interesting new tech and also repurposing of existing tech to make it more efficacious for the patient. And really interesting listening to James's presentation about the difference in temperature on the aircraft. I don't think of that because when I get on a commercial airliner, it's the same temperature. But I once saw a presentation recently by an astronaut who'd done some DNA sequencing in space, and it's really interesting how just paring back and making the kit and the diagnostics so simple that it can be used anywhere has it's really impressive that it's being used on a space station, but actually it has a real world implication in being able to use a diagnostic kit in a backwater in Africa where they don't have any cold storage. So some of that technology is really interesting and moving things forward.
Thank you very much, Simon. And just on that space note, there is a conference next week as well around space and biotech. So if people are interested and want to hear more, then there'll be people around, and Nucleus are one of the sponsors of that. But Mel, could I come to you in your role at AZ, but also in your expertise? What do you want to bring to this panel and opening remarks?
Sure, yeah, so hi, I'm Mel Leveridge. I'm a Vice President in the Discovery Sciences organisation at AstraZeneca. So in that role I lead a team who develop biological reagents, assays and run compound profiling and mechanistic studies to develop the next generation of medicines. We sit in very early discovery. Prior to joining AstraZeneca, I was at GSK for 19 years. We were sat in that kind of early discovery pharma environment. I also recently joined the One Nucleus board, so great to work with Tony and the team in that capacity. So from the point of view of the panel, what I'd be delighted to talk about is some of the novel kind of drug